All right. Well, hello, calculus students. This is me kind of preparing for what's to come in the next couple weeks. So let's see. I'm going to be practicing, the process of recording and the process of uploading my notepad online with this video. So first, I just want to talk about a couple rules, just a couple like kind of like the game plan of how this is going to work out. So soon I'm going to turn off my video and I'm going to switch it over to my notepad, and so it'll kind of just be like me writing on a chalkboard. Okay. And so the first thing that I want y'all to do is anytime we show up for class, try to do two things. Make sure your video's off and make sure your audio's off. There's no reason for us to see everybody, and I think that can kind of lower the amount of data we're throwing around. And also, if you sneeze or something, hopefully you won't. If you sneeze or something, then it won't, disrupt the class, which is nice. Or if something's happening in your house, you can kind of eliminate that from interrupting everybody's learning experience. And the most important thing is, in case somebody else doesn't turn off the recording, their audio, if you could pin my screen. So kind of see how that works. If you pin me, then in case somebody's audio isn't off, Zoom has the capability for you to, what Zoom will do is it'll show the screen of somebody who coughed. Okay, and you don't want that. So you just want to stick on me the whole time. Okay, so audio, video off, if that's possible. Later if we do things like office hours, you can turn video on, and you can, if you want to show me your writing or something like this, and you can show it up to the camera, I can look at it. That's encouraged. But for class time, please, both of them off. And pin my screen. I will sometimes ask questions because I do want to make this as much of a class experience as possible. So if I ask a question, I'll say, question for the class, I'll say that. My video will be off, but I'll say this. And if you know the answer, which I'm sure you will, you could unmute yourself and answer, theta is between 0 and 2 pi, something like that, let's say, and I'll answer. That's how I, if I want to ask a question, general question for the audience, I think that's how I'd like to do it. And also, there is some, in case you have a question, in case you want to stop me, what I'll be looking at, hopefully, is I'm going to be writing on this iPad here, and then if you have a question, I'd like you to write it in the chat. And what I'll do is I'll have the chat open, as I do right now, and I'll be able to see it. Okay, and if I see, Kyle has a question, Kyle writes, question, make sure you're writing either to the everybody or you're writing to me. I'll be able to see it. Make sure you're not accidentally writing it to some other class member. I won't be able to see it. And I'll a little exclamation point will be in my head, and I'll say, oh, somebody's got a question, and I'll be able to answer it. So that's how it's going to go. So these are the rules, and this is, I hope this runs as smoothly as possible. Okay, so what I'm going to do now is I'm going to turn off my video, as I will probably do for the rest of for most of these classes, because I'm going to turn my video off, stop video, and that's my a great picture. So what I'm going to do now is I'm going to do a share screen, and I'm going to go to iPhone, iPad, share, pull this down, and I'm going to screen mirror. Here we go. Okay. Nope, that's not what I want. It's not what we're doing. So I'm going to make a new one. And just for the rest of this video, I just want to make a video practicing how to do one of these midterm questions. Okay, So we're going to do a new notebook. Okay. And squared paper, we're going to create. Okay. So I'm going to write down the problem. So I'm going to just do an example problem for one of these midterms. Okay, so the following is from fall 2016. Oh, I'm going to set this up so I have so I can see the chat. Where is chat? More chat. Okay. Okay, cool. I'm going to chat. So there's that. Okay, this is from fall 2016. And this is midterm 2. And this is question number 9. Okay, and the question is a double integral question. So it says compute it's a double integral. I'll tell you the bounds later. The function is x times cosine of y squared. And we're going to go first y, and then we're going to integrate with respect to x. So the x bounds go from, the y bounds are starting at x squared and ending at 4. And the x bounds are going from 0 to 2. Okay. Okay, this is the function that we're given. And the question insists, they say this integral might be easier if you switch the order of integration. So the hint given, switch order of integration. Let me just tell you something that's going to be wrong. So wrong. If you merely flip everything, x squared to 4, if you just flip everything without thinking twice. 0 to 2, same function on the inside. And I'm going to be flipping my x and y, so I'm going to be doing first with dx and dy. This is wrong. This is incorrect. The problem comes from, if you have variables here, variables need to happen on innermost integrals. Okay, variables need to come on. So the problem is variables should appear on innermost integrals. Basically, the problem is that we have an x squared term that is on an outermost integral. That should not happen. Okay. Okay, so the idea is we want to draw geometrically what those bounds are telling for us. So I'm going to flip a page. If we were having a class period, I would say, is it okay for me to flip the page? And you would quickly type no, Okay, I'm going to move the page over. And so we're going to describe region given. So the given region is, well, if I go back, I'm going to go back. So it's first x goes between 0 and 2. So first those blues. So this first is x between 0 and 2. And then what is that telling me for y? What is it telling me about those vertical strips? Well, it's telling me my vertical red strips are starting off at x squared and they're ending off at 4. So I'm going to write that right here. So this is x squared up until 4, and I'm just going to draw that picture. So first, my x, am I using the same? Good. Okay. So my x's are going from 0 up here till 2. And my y's are going from, okay, well, let's draw that upper bound first, 4. And that was the upper bound, and the lower bound comes from these from this parabolic bowl. Sorry, not a parabolic bowl, just a parabola. I'm doing something like this. So the region in question is this. That's my region that we're integrating over. This is kind of like our R. This is R, and let's see. We're going to. I want to illustrate that this curve. Okay, so let me just say this curve right here is the nice one. This is y equals x squared. Okay, that's that lower bound. But now the hint for the problem says, all right, well, we should flip the order of integration. So flip order of integration really means, okay, let's get these bounds in a different direction. So let's do y first, and then let's do x. Okay, so as always, we're going to be describing this region right here. So let's think, what are our y's ranging between? What am I going to put here, and what am I going to put here? Okay, this is where I would ask the class, okay, who thinks they know what the y bounds are going to be? And say, turn on your mics, say something. Anybody take a guess? Gonna wait a while. Maybe nobody's answering. I'm going to say, well, the first set of bounds is always the easiest. They're just constants. They better be constants. What is the lowest constant for y? And what is the highest constant for y? And someone's going to turn their mic and they're going to say, oh, the lowest horizontal line that bounds this zone is the line y equals 0, but the biggest one is up at 4. And then I'm going to say, okay, well, what's the x bound? So for each y, my x starts here. No. My x starts here and finishes out here. And remember, this curve, that y value is, this is y equals x squared. It's the same thing as x equals root y. So the lowest right here, the lowest x value is at 0. And my biggest x is out here at, which, oh goodness, okay, it's that red. Did it work? Nope. Red. Good. Which is, what is my x value at this point? That is root y. And so this is now how we, these are going to provide the new bounds of integration. Okay. So now we have everything we need to set up integral. So now we can set, oh my goodness, up our integral. Okay. So I'm gonna need this again, but let's come. So my next page. So does anybody have any questions? No. Moving on. Okay. Let's see. Hopefully, how long have I been doing this? I don't know. All right. Okay. So now the integral. Okay. Well, it's gonna have something and something, and my function was. This was my function, x cosine y squared. Let's come back and plot the same function, x cosine of y squared. Let's come back over here, and this was the original integral given by the midterm. And in the midterm, they had done it with y and then x. So we're going to come back and we're going to flip it. We're going to do x and then y. We're going to do dx, dy. And then, well, we're going to use these bounds. So our outermost are our two constants. We're doing 0 to 4 on y. Let's do this. Okay, so our dy is going 0 to 4. All right, cool. And then what is our x doing? Like, I got to fill in these blocks here, right? And that's coming from my x bounds. And well, there we said the lower x bound is 0 and the upper x bound was root y. So I'm going to come over here. Now let me see if I can undo that. Nope. Oh goodness. Good. Okay. We said the lower x bound was 0 and the upper x bound was root y. And now supposedly this integral is easier to do than the original one that the midterm had suggested. So let's go ahead and let's see how that's doable. So let's do this. We're first doing an x integral. All right. We're first doing this x integral, and how do we integrate x? Well, x, I keep that outermost 0 to 4 y integral, but when I integrate x, I get x squared over 2, so I've got x squared over 2 times cosine y. Remember, that's a constant with respect to x, right? And we're evaluating from my blue bound. So the lower blue bound is 0, my upper is root y, and then we'll evaluate that, and then later we'll do a y integral. So let's see what happens. When I plug in my topmost bound, I'm just going to get the following. So I'm going to get, well, if I square root y, I'm going to get a single copy of y. So I've got y over 2 times cosine of y squared. And then, well, when I plug in 0, by multiplication, I'll get minus 0. So this is now the integral we're doing. And if you look at this, you stare at it long enough, you're like, oh, I can do this. This is, I can do this by u sub. So let's do y squared. So I'm going to write, this is use u sub. Okay. Now my y squared, I'm going to call that u. Well, that's going to make my 2y dy equals du. Ooh, goodness. Undo that. Du. Okay. And so if I see y dy, that's just 1/2 du. And my integral in question now becomes, okay, we'll figure out the bounds in a sec, but wherever I see my y dy, that becomes a 1/2 du. So I still have that 1/2 remaining from that from that 1/2 you see in that denominator right here. Oh, well, now I've got cosine, but not with y squared. That's easy. That's just a u. And then remember, my y combined with my dy gives me a 1/2 du. The last thing I've got to do is figure out what my bounds are. Okay, so remember, if my lower bound was y equals 0, that tells me that u should equal 0. And if y equals 4, that tells me u equals 2. So I'm really doing the integral from 0 to 2 of this thing, du. This is pretty easy. I mean, if you already know how this is going to go, you can finish the video right now, but just for completion, I'll do it. So I'm gonna pull that 1/2 and 1/2 out as a fourth. So let's do this. Come on. This is 1/4, the integral from 0 to 2 of cosine of u du. All right, let me just make sure that's everything. Okay, yeah, the quarter, 1/2 and a half, 0 to 2, and cosine of u du. So this is going to give me, well, how do I integrate cosine? I've got to, well, the derivative of cosine is sine. No. The derivative of cosine is negative sine. So the integral of cosine is positive sine. So I've got sine of u, and I'm evaluating from 0 to 2. And this is all right, because, well, I don't know what sine of 2 is, but at least I can write it down. So I've got sine of 2. I'm going to subtract sine of, when my u equals 0, and that gives me a 0. I know that that puppy right here, that's a 0. And so my final answer is going to be 1/4 sine of 2. All right. Okay.